Class. So now that we know what the binomial theorem is and the involvement of the Pascal's triangle in the basically in the localization of the binomial coefficients, then let's take a look at a little bit more problems, a few more problems involving the binomial theorem, which are a little bit more complicated. So pay attention to these problems because in this exercise in the book in exercise 1.0, these problems in here, they revolve around these ideas that I'm going to show you next. So let's take a look at this. Okay, so let's begin with the first problem. Find the term in x to the 9 in the expansion of the following binomial. So first, guys, what I need you to understand is the meaning of this phrase, the term in x to the 9. What this means, guys, the term in x to the 9 is basically the term in the expansion of this binomial, the term whose variable part is equal to x to the 9, right? For example, let's take this binomial to the fifth. There you go, okay? And then I need to expand it. So let's begin with the formula of the binomial. That's going to be equal to 5 choose 0. Then you just keep going, right? Remember that your n is 5, so you begin with 5 in here, 0 here, and so on. So let me write down all the terms. Make sure that what I'm doing is correct. And this is the final term. There you go. Okay, and then now with the help of Pascal's triangle, we know how to calculate this number, this number, this number, this number, this number, and this number. And they are known as binomial coefficients. Binomial coefficients. How do you get them? You construct Pascal's triangle. I'm gonna construct it in here. You begin with 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. I think by now you get the main idea, right? Okay, and we can stop right here because since our exponent is 5 in here, I only need to construct the triangle up until the fifth row. Remember that we start to count from this row, that's the first, and that will be the fifth. This will be the fifth row, and these numbers, guys, these will be our binomial coefficients. Okay, so 5 choose 0 is 1, 5 choose 1 is 5, etc. Now, remember, what are we trying to do? We're trying to find the term in x to the 9. And so basically, guys, which of these terms, either the first one, the second one, the third one, the fourth, the fifth, or the sixth, which is the one that will have a variable x raised to the 9 after you simplify as much as possible? For example, looking here, your variable is raised to the cube and then to the 5. So out of here, you will get x to the 15, right? And in here, guys, x to the 3 to the 4, you will ultimately find x to the 12. That's going to be the variable part of this term. Now, what about here? X to the 3 to the 3. Eventually, when you simplify this term as much as possible, you will get a variable part of x to the 9. So this is the term. This is the term that is known to be as the term in x to the 9. So let's actually calculate all of this term, guys. How do we do it? Well, we know that 5 choose 2 is going to be this one, right? It's going to be 10. So let me put it in here. 10. And then we elevate 2x to the cube. We're going to get 8x to the 9. And then 4 to the 2, which is 16. Okay? And then finally, we just multiply all of the coefficients. 10 times 8 times 16. That's going to be equal to, well, how much is this? It's going to be 800 and 480. So that's going to be 1280 if I did this well. And x to the 9. So there you go. This is the term. This is the third term. This is the term that belongs right here after you simplify as much as possible. Okay, and this is the term, guys, that is known, once again, as the term in x to the 9. In Spanish, this is known as el término en x a la 9. En otras palabras, sería el término que tiene su x o su variable x elevada a la 9. So that's it, guys. That's basically what they're asking from me, to find this specific term. That would be the solution to this question. Okay, let me make a pause, and then we'll continue in a moment. Okay, we continue with the second problem, which is similar to the first one. Find the term in x to the cube in the expansion of the binomial, this binomial, to the sixth. Okay, in theory, guys, in theory, we can solve this problem in the same way I did this one. Okay, so basically we have this binomial to the sixth power. We expand it. We know that there will be 7 terms. 1, 2, 3, 4, 5, 6, 7 terms, because the power is 6, right? So there will be 7 terms. And then we just basically spot that one that has x to the 3. And that's what is known as the term in x to the 3. Now, this could be a little too much work. There's a very simple way to find this term in particular without expanding the whole binomial, although you can do it if you want. And that quick trick is basically realizing the following, guys. Let me erase this. The quick approach that we can take is the following. Understand that the first term in the expansion of the binomial, when you only take a look at the variables, like forget for a moment about the binomial coefficients. Okay, so that in this case, forget about 6 to 0. Let's, whatever number this is, we don't care. So let me just put it in blanks like that. And then, what is the next factor that appears in this term? It's this number to the 6, right? And then the next factor that appears is all of this number to the 0, right? And therefore this is the first term. Okay, plus then the binomial coefficient 6 choose 1, but we don't care about that for the moment because it's just a constant in the end. And then the first number to the 5th, and the second number to the 1, and so on. And realize the following. When you elevate x squared to the 6th, you will get x to the 12th. And when you raise x to the 0, you will get x to the 0, which is eventually the same as x to the 12th, minus 0, which is eventually x to the 12th. So basically, guys, the variable part of all of this term will be, in the end, x to the 12th. Okay? I'm only getting the variable part of all of this term. It will be multiplied by a coefficient that I'm not getting because I'm not interested so far in the coefficient. I'm only interested in the variable part. Okay, so forget about this coefficient for the moment. And let's do the same. Let's do the same for the second and the third term. For example, in here, what's going to be eventually the variable part? of this term? Well, we get x to the 2 to the 5, so we get x to the 10, right? And then we get x as a denominator raised to the 1. So basically, in the end, after you raise this denominator to the 1, you will have x to the 1 as a denominator. And after you perform the loss of exponents and you simplify this, you will get x to the 10 minus 1, which is equal to x to the 9. So ultimately, after you simplify this term as much as possible, you will get some coefficient multiplying x to the 9. Okay, and let's do this experiment once again with the next term. Okay, we will get a binomial coefficient. We don't care about this number. This is the third term. And then two factors, x squared to the 4 and 2 over x to the 2, right? And let's just focus, once again, let's just focus on the variables. Not this coefficient, not this coefficient, just on the variables. So x to the 2 to the 4, that's going to be x to the 8, over x as a denominator raised to the second power. So after I perform that exponentiation, I will get x to the 2 as a denominator, and then I apply the loss of exponents. There you go. And finally, we get x to the 6. Okay, so eventually, after you simplify this term as much as possible, you will get some coefficient, we don't know what coefficient, times x to the 6. Okay, and then you can see the pattern, guys. You can see the pattern here. Look. Okay, there you go. Look. This term, and this term will eventually, in the end, have these variable parts. This variable part, x to the 12, and then this variable part, x to the 9, and then this variable part, x to the 6. And you can see that a pattern starts to appear. These exponents in the variable parts, in the x, are going down by minus 3. Can you see? 12 minus 3, that's 9. 9 minus 3, that's 6. And yes, as you may be guessing, the next variable part, let me move this up. The next variable part in the next term, which is the fourth term, first, second, third, fourth term, that's going to be x to the 3, because the pattern will be kept constant. So what is the bottom line here? The bottom line is this, guys. The term in x to the cube is going to be here. It's going to be the 1, 2, 3. It's going to be the fourth term in the expansion of this binomial. That's the one that I'm looking for, the fourth term. That's going to be the term whose variable part is x to the cube, and therefore that is the term that is understood as the term in x to the cube. So that's it, guys. We only need to get this one. I don't really care about this. I don't really care about this. I don't really care about this, nor I care about the remaining terms in the expansion of this particular binomial. We want the fourth term, because that will be the term in x to the cube. So basically, let's find it. Let me erase everything. This is my binomial. There you go. And I'm looking for the fourth term. So basically, I'm going to use my formula for the kth term, right? And in here, for this particular problem, my n is 6, because that's the exponent. And my k, which is the number of terms that I'm looking for, is 4. Okay? So that's it. So the fourth term is going to be equal to, if I write the formula like the way I told you before, it's going to be equal to this, right? And then all I have to do is substitute n and k for the respective n and k that I have for this problem. So here we go. We get 6, and then 4 minus 1, and then you know the whole thing, right? A is my first number in the binomial, raised to the 6 minus 4 minus 1, And then comes b, which is the second number in the binomial, which is 2 over x raised to the k minus 1. So there you go. After we simplify a little, we get 6 choose 3 raised to the x squared. I'm sorry, 6 choose 3 times x to the square raised to this number, which is 3 times 2 over x raised to the 3. And then we get this combination. I don't have the calculator by my side, guys, so you're gonna have to help me with this. 6 choose 3, and then x to the 6, and then 2 to the cube, which is 8, x to the cube, which is x to the cube. There you go. That equals 6 choose 3. And then we have this. We have x to the 6 times 8. So we're going to get 8 x to the 6 over x to the 3. And finally, over here, we can simplify this x to the 6 over x to the 3 as the following. Okay, x to the 6 over x to the 3 will be eventually x to the 3. And so as you can see, after you find this number, 6 choose 3, and then the multiplication times 8, and then the multiplication of x to the cube. So basically, you will have a term in x to the cube. That's how this is called, guys. The term in x to the cube. Okay, so find this multiplication, do it on your own. Well, let's actually build very quickly the Pascal's triangle. You will very quickly memorize the first rows if you do this frequently, right? So this is the one we have. This is the one we need, the sixth row, because the exponent is 6. So 6 choose 3, that's going to be this one. This is 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3. It's 20. So it's 20 times 8 times x to the cube. So we have 160 x to the cube. And this is the answer to this particular problem. Find the term in x to the cube in the expansion of the binomial this to the 6. The answer is 160 x to the cube. Once again, this is known as the term in x to the cube in the expansion of this binomial to the 6th power. Okay, guys, so I'm going to keep it there. Let's do this one live. I'm going to do this one live with you. And so that's it. Thank you.